Hello, everybody. I'm Samarth. Today's workshop is an introduction to backends. The workshop is going to be a mix of me explaining things and some live code demonstration, along with just testing what goes on in a browser so we can see what's happening. So first, we're just going to start with a high-level overview of backends. You can read the README over here. You don't need front-end experience to be a part of this workshop, though I will do a little bit using fetch later on to show how to do backend. And if we have time, I might do a little bit about async await or promise chaining, because that's quite related to how a backend works. Well, how you get data from a backend. The first question you might have is, why do we need backends? Some of you might have built an app, maybe in CS35L, where you used a Firebase database and you plugged it directly into your React app and you just ran everything off that. And it was probably pretty easy. Maybe you didn't, but I know a lot of people did. And so you might think, well, why do I need this separate program to run, which I have to make calls to? It seems like a bit of a hassle. And the most important reason is you very often don't want code that directly connects to your services to be running on your client's computers. And this can be for a variety of reasons. So let's say I needed to do something very intensive, computationally expensive. I wanted to compress a really large PDF, if you've ever seen a PDF compression website online. And imagine someone had a really slow computer. You wouldn't want the speed of their experience on your website to be determined by the speed of their computer, which is one reason to not want to run locally. Another, probably more important reason to not want to run locally on people's computers is security. When you have things running on your own server that you've deployed, you know what's happening. And you don't necessarily know that someone's not going to tamper with what's happening on your local device. You don't get the same level of protection, and you can't be sure that the code is running the way you want it to run. So especially if you're like in contact with your database, you might want to do that from a separate program hosted separately by yourself instead of directly off the person's computer. So like it says here, backends are frequently used for authentication and database serving, which may not be safe to do locally on a client's device. So what do backends do exactly? So this is a graphic I found from Google. So at the top, you see your front-end frameworks. This is a full stack blueprint. So it's basically a blueprint for a full stack application using certain technologies. You can obviously do it with other technologies. So here's HTML, CSS, JavaScript, Bootstrap, jQuery, basically your front end, or you can use React or Angular or Vue or whatever you want to use. And then there's the backend, which interfaces with this, but you'll notice the backend also interfaces with a database and with external APIs. Like in this case, it's interfacing with Google Analytics. It's interfacing with SendGrid, which I think was a mail sending service. And we will skip this part over here, but it also interacts with servers. So the backend is sort of the glue that ties your entire program together and gets it all to work very well. There are a lot of different programs you can write a backend in. My personal favorite to write backends in is Go, but I decided not to do that because it's not as mainstream as Express. Well, it probably is an industry. But right now, a lot of membership portal code and stuff is written in Express, so it was probably a good idea to learn right now. You can also use Flask or Django, which are two Python libraries to write backend code. And you can also write backends in Rust and PHP. I don't recommend that one. PHP, Rust is pretty good. So all the backend does is interface with the database, whether you run it locally or you run it in the cloud, and it basically does computation. Like, for example, if you were to create a user account, it would go to the database, add a user entry, maybe store their password, or in the case you're using like another service to do your authentication, it will like interface with that service, and then it would like create all the information pertinent to your application for the user, and then it would return a response to the front end, so your front end doesn't have to run any of that code. So it basically takes care of all of that. Does anyone anyone have any questions so far? Okay. So now we'll talk about endpoints and handlers. So endpoints are, well, it says endpoints are network nodes that clients can connect with to perform certain actions or get certain information from a backend server. What that basically means is an endpoint is basically a URL. You fetch data from it and you get data from it, and then you can use that data whatever way you want to use it. We'll see in a bit, in fact, after we set up a few endpoints in our application, that we can actually directly call them from the browser. Or if you want, you can just like get data from an API endpoint using curl in the terminal if you're feeling so inclined. So requests have methods, API requests have methods. So the method is the type of request you are making from the server. So you can make different types of requests. The main type of requests are given here. The names are reasonably self-explanatory. So get request, get something from the server. What's important to note about a get request is it should be a stateless request, which means it shouldn't depend on the user log data. It should be constant coming in. Post is used to post data, send it into the server. Maybe if a user wants to perform an action that adds something, let's say you have an editor and the user adds a document in like a text editor online. That's when you might use a post request. Put is when you already have an item and you want to update it. And delete is, of course, when you want to delete something from the API. Secondly, the URL is the address at which you would like the clients to perform the action. So like I said, we'll set up a few endpoints in a bit, and you can see how you can directly pull data from the endpoints and view it in the browser. It'll just be like going to a website. Of course, you don't really use it like that in real life because no one wants like big chunks of JSON data. And of course, like your application processes it and does what it wants with it. It might display it, it might use it for something else. But yeah, so for example, get /users could be an endpoint that corresponds with getting a list of users, and post user/create would create a new record of a user with the information included in the body of the request. Excuse me. So these are different endpoints. So we're now going to talk about a request body. So your request URL can only contain so much information, and you often want to send more information to the server so it can do things with it. So general HTTP requests have a URL. They have headers, which we will talk about, and I will show you one header in a bit, and a request body. The method, which we saw before, these four: get, post, put, delete. There are others, but these are the main ones. Specify what we're going to do, what the endpoint does, and the header specify information about the request. So one of the headers you will see in a bit will be content type. And generally for the work you will be doing, you'll be setting content type to application/JSON, which means the input data being provided in the request body is of type JSON. So the body is where the data is placed to pass it to an endpoint. In particular, it's used for post and update requests that require form data. So going back to the analogy of creating documents associated with a particular user, the information about what's contained in the document would be stored in the body of the request. Because I'm sure you can imagine it'd be quite silly to put the whole thing in a URL. So here's just a quick illustration of what's contained in a request to a backend. You can see there's a method, there's a URL, there are headers, and there's a message body. So I'm sorry, the lights automatically turn off in my room. My roommate will take care of that. So we will now talk about what handlers are. So we've talked about what endpoints are. Endpoints are essentially the URLs at which you get data from the server. So a handler is a function that handles a specific API, a request sent to the API. So you ask the endpoint for an action, you ask it to do something, and the handler is the function that does the thing you want it to do. So how do I make an endpoint and a handler? So now if you guys feel like it, you can just open whatever text editor you like, and we can like start working through this simple piece of Express code. So typically in any framework, you specify the handler and then register the handler with particular endpoints. We'll demonstrate this. It's pretty straightforward. So specifying a handler requires you to define a function that performs the action. Suppose we want to have an endpoint that returns hello at the URL hello. So I'll just demonstrate how this would work really really quickly. So as you can see, I'm writing code over here. So we first import the Express module, then we create an Express app like this. It's how you instantiate an Express app. Then we set a port that we want our app to run at. And then this is the URL that we want the app to run at. So it'll run right now on your local machine. I'll run it localhost port 8081 and localhost port 8081/hello will give you the response from will trigger this endpoint. And now the first argument is the URL and the second argument is a function. So I assume most of you are familiar with arrow functions. So I'm just going to use one over here. And this function takes in two arguments. It takes in rec and res, which in this case is the request and the response. The response is the data returned back from the API to the client that made the API call, and the request is the data that was passed to the API. It contains all that information. So in a bit, we'll actually explore what kind of data can go inside the request body. But for now, we will return response.status 200, which means a 200 status means, okay, nothing's gone wrong. You've inputted valid data. The backend was able to process your request, and we'll have it send just plain text right now that'll say hello. And finally, to get this app to run, we'll get it to listen on the port that we have, and we will just print out some text to let our program know, to let us know that the app is running on the correct port. So now I have the app in here, so I should be able to run it. That's wonderful. Cannot find module express. That's really odd. Right, and then I can node app.js. There we go. So now we see the example app is listening on port 8081. So now for us to go to localhost 8081/hello, you should see that it gives you hello. And you can see it is getting data from here. There's no match about this. If I want to change this to anything, oh wait, I need to refresh the app. You will see that the API returns data. So this is pretty simple. We imported Express. We instantiated an instance of the Express object, the Express app. We declared what port we wanted. Of course, you can always just specify the port here, but it's generally good practice to store in a variable. And then we created an endpoint. So this uses the method get, as you can see, app.get. It works to the URL at hello, and it also takes in an object that has a request and a response object as its argument, and you can send with the response a status of 200, which means, okay, this response was good, and you can send some data with this. We generally don't directly send things. It's generally good practice to send JSON, because that way it can easily be destructured at the other end, converted into a JavaScript object if you're working with React, and you can work with the data that comes back more easily. So here, app.get is supplied the URL, basically what I said, and it supplied an anonymous function that takes in the request and the response body. So This is all pretty straightforward. I'm gonna now show you something that will make more sense in a bit, but it's just good for demonstration right now. We will define this app.use at the end that should return a status of 404, which you probably know is the status for not found on the internet. And what happens here is if the app is not able to associate, excuse me, a request made with any URL, it falls back to this at the very bottom, and it returns a status code of 404, and it sends a message to the response that there was no response from the API. So this is good because it prevents crashing if you try to access an endpoint that doesn't exist. So just test if this works to show you guys. Hello works fine, but if I was to change it to hello E to see if it changes something, it says API doesn't exist. And if I was to change it to literally anything, it'll say API doesn't exist. And in contrast, if I didn't have this and you try to run it, you would see that it had a crash. When it would crash if and give an error response that was not controlled by you. So when we talk more about middleware later on, you'll see this in more detail, but this is just good practice to have a 404 handler for endpoints that are trying, when the user is trying to access endpoints that don't exist. So this is all great, but this seems kind of lame. I mean, you can do very little. Sure, maybe if you had like a news feed, you could access the data from like different endpoints, but there's no way for you to supply your own data, and there's no way to like get variable information. So we'll talk about a few ways to access variable information from the API, from the backend. So the first thing we're going to talk about is path parameters. So path parameters are basically variable parts of a URL. So they are whatever they can be. They are whatever you set them to be, and you can access them. So real quick, I'm just going to write a quick endpoint to show you path parameters. So here we declare an endpoint that's at users/:ID. Now, you might be wondering what this :ID is. All this says is that this field can be whatever it wants. And inside our request object, there will be a property called params, and we can access the ID as requests rec.params.id. And so the user can input whatever they want here. And just to show you that this works, we will send back the params so they get displayed in the browser. And so now if I was to go to user/ABCDE, it shows you that this is being passed. And of course, we wouldn't typically want to show this in a browser. We typically return this data. And so it could be used. Of course, we wouldn't directly return the param send, but the JSON data that would be returned by the API could be used. If you want to return JSON data, you should change the send to .json, but we will get to that in a bit. Path parameters are generally used for get and delete requests. And this basically says what I just demonstrated. So another way you might have often seen, particularly in search engines, or in websites where you search for something with like variable URL, like string, you enter a search query, you see it in the menu bar, followed a question mark separated by a bunch of characters, is called a query parameter. So query parameters are essentially followed by a question mark. So you have your URL, a question mark, and then query parameters that are essentially set like this. So field 1 takes value 1 in this case, field 2 takes value 2, and so on. So real quick, you can see an example of query parameters. I'll just write out a quick piece of code to demonstrate this. So we again write a request that uses the get method. We assign it to URL query. In this case, you notice we didn't need anything like the :ID over here. So we simply have the request and response object. And we return a response status of 200, and we send, in this case, I'll just send some JSON data because this does seem like a basic JSON object. Test data. And so, wait, no, sorry, I messed up. In this case, we get our params, which we will set when we make the request. And we'll let param2 be equal to rec.query.param2. And we return a status of 200, and we just send the user back the params input. So you input param1 to be param1 and param2 to be param2. And you should now see that. So if I was to go here and I was to go to query and I set param1 equals this is a param, and I was set param2 to also a param. It's right, my bad. I think this was, yep, there we go. And there, so you can see whatever param set up gets shown here. And this is essentially how you can access your params from inside your request. Like I said, often is seen when you make like searches using a web browser or like search for a specific thing in a web page. So form data is generally used for post and update requests. I would demonstrate a post request. Maybe I'll show how to access a request body when we use the fetch API. But these things generally require a database to set up. But they're not too dissimilar from what we've done right now. So I don't expect to be particularly difficult to pick up. So now we'll discuss how to get data from an endpoint. So far we've been doing everything in the browser. You will likely be working in React. And React offers, and JavaScript offers, what's happening? A special way to get data from an API endpoint that's non-blocking, which essentially means if you're running your program and you want to get results from an API, it won't freeze the whole program up. It'll actually get data from the API. It will make a call to the API, will continue running the rest of the program. And when the data comes back from the API, it will come and insert that data wherever it needs to go or use it for wherever it needs to be used for. So real quick, I'll just show you guys how to do that. So this, I'll do this in a file called fetch. Note, because I'm doing this inside a JavaScript file, not a React app, I have to name my file .mjs. I also will likely have to install node fetch because that doesn't come by default. So the only reason the file is called .mjs is because the module we're going to be using, fetch, is an ECMAScript module. So I can't use it using require, which means I can't use it in a common.js file. So I need to use it in a .mjs file, but this won't be an issue when you use React. So don't worry about it. So let's just set a URL to be where we want to get data from. Right. And then we'll use the fetch function. So there are two ways to do this. I'll explain both of them, but first I'll just write them out. So here we set the headers. There is content type. These are headers. You also send the body through here. But if you want to do that, then you have to put the headers inside an object with key headers and then put the body as another key and then assign a JSON object to it. Maybe I will show you how to do that in a bit. So we set content type to be application.json, which means the request body type should be a JSON file. And then from there, I simply, so fetch returns this thing called a promise, which I will explain a bit. Wait, have people learned how to use promises in Async Await? Okay. So I'll show you guys how to do that. So I get data. So essentially what this does is It fetches data. Fetch returns this thing called a promise, which essentially is a guarantee that says we will give you your data or we will give you an error. In the case you have an error, you have to catch the error and print it out. Otherwise, you fetch the data and it knows it's going to take a while to fetch because it needs to get it from a web API and that might be slow. So it removes this from the flow of the program. It hands it off to a web API. It runs the rest of the program. And when it's done, the web API puts it back on the program execution stack and then it runs it. So that's essentially what fetch does. So we fetch the URL. The dot then means when the response comes back, we take the response and we want to return the JSON data in the response. And then once we have the data, because even extracting the response from the JSON doesn't happen immediately, it's also another async thing. It's another thing that gets taken off the event queue, and when it's done, it gets put back on. So the rest of the program can run. It's non-blocking because you expect it to be non-blocking. If you were coding up a React app or any web app, imagine if you like click the button to do something and the entire interface just froze and stopped working. And we'll just console.log the data that's being provided. And so we'll now show an example of an API endpoint which returns JSON, which really isn't too different from what we've been doing before. It's app.get JSON, and it has a request and a response object. And the response object returns a status of OK, because again, we've hit a valid endpoint, and this time we send this data. So here we go. And I need another terminal here, which is all right. So now we have the app running, and now we want to run this file. So I will. It's a file called fetch.mjs. So node fetch.mjs. Protocol.replace is not supported. Node fetch cannot load URL. It's odd. One sec. Give me a second.
I think you have the wrong URL.
Do I? Yes. Thank you. That explains a lot. Don't know how I messed that up, but okay, it happens. And there we go. So as you can see, it ran the code and it returned the correct JSON data that we wanted. We didn't have to output the entire data. If we just want to import output the value of test, actually that might not work. If I just wanted to do that, I likely can. See, and it outputs the value that's associated with that key. And as you can see from this, you can make a call to the API, it will return you JSON data, and that will be converted into a JavaScript object, and you can access that however you want to use it. And so that's one way of doing it. The other way of doing it that some people prefer and some people don't, but is considered more modern, is to use this thing called Async Await, which still uses promises under the hood, but just has some notation, easier syntax, I guess. So you declare an async function called fetch data, which takes in a URL as an argument. It expects a response object, and instead of getting a promise, instead of chaining promises together like we did today, we use the await keyword to fetch the URL with the content type application/JSON. So all this await means is do the same thing. All the data that's going to be all the variables and other parts of the program that are going to interact with this response, only run them once the promise that's going to be returned by fetch resolves. And then again, we can do const data equals await response.json, and then when return the data. So there's no chance of return prematurely because this will only run when the response is returned, and data will only return when the response has been converted into a JSON file. So if you'd prefer to do this, we can always wait we get the data, because this is an async function, you have to call await to use it. We set the data to call this function. We wait for it to finish executing, return what it needs to return. Again, remember, we need to call await because it's an async function, and then we can log the data. And that should also give us the data. So both these methods are equivalent. Both of them work. Keep in mind, if you were to do this, these are non-blocking. So for example, I'm not sure how quickly the API call will be made. So there is a chance this runs before this does, but I would expect that test is printed before the result from the fetch. And as you can see, it prints test first because the program is run asynchronously. It's not run in order. So this basically means it's non-blocking. So I hope that makes sense. This is a pattern you will likely be using quite often. And if you're using JavaScript for code, again, when you're working on it, you won't have to worry about importing node fetch. So all of this basically specifies what I said a while back. If you want to read up more about this, I think there are details later on the README. If there are not right now, there will be at the end of this presentation. And so now we'll talk about databases, because those were that was one of the key things that the backend interacted with. So there are two main types of databases. Well, there are only two that I know of. There might be more, but I don't know of them. So there are SQL databases and NoSQL databases. So SQL databases, SQL stands for Structured Query Language, and SQL databases are basically characterized by data structured in tables, and the data is organized by columns. So it's pretty straightforward. Like here, there's a fruits table. There's an ID. Each fruit's assigned an ID. It has a name. It has a quantity. So this table is probably for maybe a groceries vendor, and it has a price and it has attributes. So seasonal, false, the color, and rotten, and things like that. So you might think that the data here looks a little weird, but that's because SQL doesn't have a serializable type. Sorry, they don't have a map or dictionary type. So you can essentially serialize the data, which means turn it into a long string. And you can turn your like Python dictionary or your Go map or whatever you want, or even a JavaScript object into a string and extract data from it later on and deserialize it later on. That's essentially what that says. So it's pretty simple. There's not enough time in this lecture to cover all of SQL, so I'll just show you a sample SQL query. So to retrieve, add, modifier, delete information from SQL databases, you essentially run queries. These can be performed in the console connected to databases, though if you're working with an Express backend, you will likely be using a library to connect to the database. I have used PG Promise. I have had a pretty good experience with it, and I recommend that, but you can try all kinds of things. I'm sure there are a lot of them. I think like 3 or 4 of them are a wrapper on one base library, including PG Promise, wrappers on one base library, including PG Promise, but you're free to try them out. No one would ever complain about having code be easier to write. So here's an example of a basic query returning some data from our table above. You essentially select star, which means select all the columns from the fruits table where the quantity, which is a column in the table, is less than 5. So there we go. It asks for all the entries in the fruits table where the quantity is less than 5. It asks for all the columns. If you only want some columns, you can select what columns you want. So if we only want the name and the price, we can select name, comma, price from the fruits table where the quantity is less than 5. And to insert into the table and to delete things from the table and to drop tables and things like that, the notation is pretty similar. We've left a link over here if you want to read more about, if you want to read more about SQL queries. So NoSQL databases are more fun. They're also, some might say, a little less tedious to set up, and they offer you more flexibility with what you're doing. They are slower though, because NoSQL databases likely do use SQL under the hood. because it's hard to have data that's that unstructured be processed by a computer. So NoSQL databases are essentially structured into documents, and each document is basically a massive JSON object. So for example, if we have users and their text documents, going back to the example I was talking about before, you would essentially have a users table, which contained all the users and whatever details they add in a JSON object like this. And then you would have all their text documents listed out, and each user would probably be associated with their text documents, maybe in an array in the JSON object. And each of the text documents would likely be arranged associated with the user. This does cause some data redundancy, yes, which is not uncommon in NoSQL databases, but it drastically increases performance, and you can understand why you can access anything by going through either the users or their documents table in our example. So it's essentially a big JSON object. It looks like this. Notice it says here, notice how for attributes, we're storing a map and how we can have different fields in it. So it can be as complicated a JSON object you have to be. You're not limited in any way. Unlike in SQL, you don't have to serialize, and it is easier to work with. You can play around with NoSQL here. I think that is a link to MongoDB. Yes, it is. MongoDB and Firestore are, I think, two of the most popular implementations of NoSQL databases. So choosing what type of database you use depends on your use case and what is required. I know the membership portal uses SQL, but at the same time, the code editor that TeachLA uses Firestore, which is NoSQL, Firebase, which is NoSQL. So it's very dependent on your individual needs and honestly what you're comfortable with. I will say NoSQL is probably a little bit easier because you still need to be thoughtful about your database design, but you need to be very thoughtful if you're doing anything reasonably complicated with the SQL database. So now we'll talk about middleware. And after this, I'm going to get some water. So it's good software practice to compartmentalize your code. So you don't have repeated code, and you want to abstract functionality that's repeated again and again into blocks like you do with functions, and you want your code to be organized well. So express middleware, I don't need this anymore. Express middleware are functions that are executed during the life cycle of a request, which sounds fancy, but all it says is instead of having one handler function, you have middleware, which is multiple handler functions that are chained together and run in order. So an example I could give you, if you had a request coming in for processing, you could assign the request a unique ID, then you could take that unique ID and set it in information about the response, and you would have, and after that middleware is executed, if you came to the next piece of code that does something else with the request that determines where the request goes or what to do with it, you could use that. And then maybe after that, you wanted to do something else. So then you execute a certain piece of middleware. So it's just behavior that's chained through. And at the very end, in the first piece of middleware, the ID you assigned could be returned to the user if that's something you're interested in. That probably sounds a little complicated, but it's not super complicated. Another good example I can give you is, let's say you are implementing like user authorization or user authentication. So the user entered like a username and a password. And so of course it's all fine and good to validate that the password matches the requirements you want and the username matches the requirement you want on the client's device, but that's not 100% guaranteed to work. You don't know what the client's going to do. You don't want a chance for bad data to end up in your backend to cause problems. So what you would do is, let's say for creating an account and for logging in using, let's say you log in using multiple, you have different endpoints for logging in because you might have different hierarchy of users. So in that case, you could have a piece of middleware that validates that the username is in a valid format and the password's in a valid format, and you could reuse that before any of the other endpoints ran. And so that's a way of preventing code reuse. So the most common way to write middleware in Express is using the Express router. A router instance is an example of middleware, and I will just quickly demonstrate how that works over here. So we'll name this file birds.js. And so again, we will Express, and we will then get the router from Express. So we instantiate a router object as such. And then inside this router, we have a few different endpoints. We return a status of 200, which you should be familiar with this. We have a fake about page. This is just for demonstrations purposes. I'm not sure why there's semicolons in the code. I really hate semicolons, but that's okay. And we return a status of 404 for no birds were found here. So now we have set up our Express router function, and we just need to export this. So we set it in our module.exports. So this entire thing will serve as middleware, and I will show you how very quickly. So the code sets up a router as a module and defines some routes. And so if we can use, to use this in here, all we do is this to view var. We get the birds from the birds file, and we just use the middleware. So app.use birds. So what this does is at every point that's /birds/anything, it redirects it to use this router. So if I had just /birds, it would give me birds homepage. If I had /birds/about, it would give me the about homepage. And if I had /bird/a string that was not a valid URL, instead of defaulting to our old 404, it would use this one. So how about we try all these things? What did I mess up? Right, an equal sign. So here we go. We will try this out. So 81/birds. We're at the birds homepage. If we were to go to about, we'd be at the about page. And if we were to go to about whatever, I don't think I should put that in. No birds were found here. If I was to change this to anything, there'd still be no birds found here. So as you can see, this piece of middleware essentially allows you to abstract out functionality and not write like all the different handlers. You can abstract everything about birds into one group. So this is just one example of middleware. Now you might be thinking this isn't super related to the examples I gave you before. And so now we'll talk a bit about those. So we will now demonstrate a piece of middleware that runs at the beginning of every API call. So like I said, we could do the UUID thing, though in this case, I'll just write a simple piece of middleware that logs something for every request. So here you will see I have app.use at the beginning, and this connects back to the 404 thing I said, which we see before. I have an app.use at the beginning. Because it's before all the other endpoints, the order matters in this case, because it's before all the other endpoints, it is checked before all the other endpoints. So in this case, I want it to run before every call. So I don't give it a first argument for a URL. I just pass it a function which takes in a request, a response, and now there's something new, a next function. So we'll see what this does really quickly, but I will console.log. We are in middleware. Cool. So, and I will pass next. So all the next function does is the API call comes in, it sees, it fits this handler because it doesn't have any URL, so it fits every URL. It prints what we want it to print. And what next does is it tells it, go to the next handler function that matches you. If nothing matches it, then it'll end up at 404. If something does match it, it'll end up here. And essentially what res.status does is it returns a response object. You could not return a response object. You shouldn't, because that would probably cause issues for the front end. But if you weren't to pass next in this case, it wouldn't fall through and it wouldn't go to the next handler. It would just stop the program right there and it wouldn't return anything. So let's just see what that looks like. We'll run the app again. And I forgot simple things because that happens. Request, response, next, arrow function. Right, yeah. Okay, so now if we were to go to anything, if I was to go to hello, I see it. We are in middleware. If I was to go to user/test, I see ID test, and we're still in middleware. If I was to give a completely invalid URL, we're still in middleware. It still prints it. It still runs it. So like this, you can put your middleware in a different file. You could chain it together. So if I had another piece of, if I had an endpoint and I wanted it to run one piece of middleware, I could first add that piece of middleware, then add a comma and then add a second piece of middleware, then add another comma and add a third piece of middleware. And like that, I could chain them together and they'd all run in sequence. And all that's important is you have this little next command over here, which tells it to go look for the next piece of middleware. And if you want to test it for the birds, it still runs. It's still a middleware. So I hope that makes sense. And I hope you see this can be useful. One of the main places you're probably thinking it is useful, and it is in authentication. If the user has a token or some kind of credential that needs to be verified before they're allowed to make an API request, you can add middleware that checks if they have authorization to access the database or any specific data or anything, or make an API call to an external service before they make the call. And so middleware will allow you to do that without having to implement the auth check into every piece of code. So that is a very nice piece of Express. This is essentially what I said above, though if you want to read it, it's over here. And we'll now just talk a little bit about authentication. It's hard to talk too much about it because you need to set up a database and have a lot of things running. But this is just a high level overview. If you are curious, there are more links written. So one way you can do authentication is DIY. It's not that bad. It might sound really difficult. Oh, you need to encrypt passwords and make sure everything stays safe and like either pass a JWT token or contain data about the user session, but it's not that bad. You need a users table / collection. So SQL or no SQL database, you store the user's data in there. It should probably have at the bare minimum an email field or username field, but an email field is better because you can associate that with a person to contact them after they make an account, which is likely something you want. And then you have a post request to an endpoint to create a users table and a post request to another endpoint to log in a user, with a handler to query the table for a user with the expected email and password. Now, of course, you don't store the password as a plain text file. That's not good practice. So what you typically want to do is use this library called Bcrypt to hash the password. I'm using a secret key that's stored with your backend. No one else should have access to this. And then you solve the password. And what that essentially does is if a hacker was to get access to your password, they wouldn't be able to do anything with it because it's hashed. And if you are curious about how secure hashing is, there is a 3 Blue 1 Brown video on how secure is 256-bit encryption. It's a very interesting video. Go watch it. So here it says you should use a third-party library to deal with the encryption and checking, since you definitely will most likely not implement it correctly yourself. I've used Bcrypt. I've heard that is pretty popular, and it is pretty popular. So if you ever want to do that, I recommend you do that. Of course, you can look around for other libraries. Secondly, once you create information about the user, you want to create. So there are 2 ways of doing it. Well, there are more than 2 ways of doing this, but there are 2 ways that I know of doing it. You can either have a sessions table where in the database, you store the user sessions and the key associated with that session. So every time the user wants to use your API, a request is made to the database, and the middleware authenticates this, authorizes, sees the session key, checks with the database, it sees, yep, this user is currently allowed to access all this data, and the user is allowed to access all the data. So the backend checks if the sessions in the session table. This checking can easily be implemented for multiple endpoints by checking for user authorization and express middleware. Like I said above, and I hope you guys can imagine how express middleware would be used in this case. There are other ways of implementing logging by yourself, such as using JWT tokens. You can learn more about that over here, but this is a little different. In this case, you have a token that needs to be verified against a secret key that's again stored in your backend. And the token contains information about when it expires, and it will expire after a while. You can set it to not expire as well, though that's generally not great practice. So another way to do authorization is using SSO. So, which is essentially single sign-on. So these days you often see sign in with Google, Apple, Facebook. I haven't seen Amazon, but I'm sure it's there somewhere. They basically let third parties deal with the authentication and authorization if you don't want to do it yourself. So generally, you make a request to the backend makes a request to an appropriate API call. In fact, if you ever see the membership portal code, you'll see how Dylan implemented authorization using Google SSO before it used to be done manually using Bcrypt. The third party will return a token if the authorization is successful, and a profile ID. The profile ID is assigned to the user in the database. You still, of course, need to store the user because the authentication will only take care of authentication. And so the token is a string that marks the user signed in. It's not the same thing as a session, but it is pretty similar. On the back end, whenever a user should be signed in, you check the token and the third-party API, see if the user signed in, and you can associate the profile ID given it with the data you want to store. So like I said, you have the user ID, you store that in the database, and you can use that ID to access the user and store them with whatever data you want. So today we learned the basic principles of backend and how to use Express to build middleware and routing. This is the last workshop of our training for this year, and committees will have more specific training should you need any. We hope you had fun, and I hope you learned something cool, and I hope you learned something today. Thank you for your time.